Hey guys, it's Gia.
And Natalie, ready to talk about ecosystems and energy?
Organisms can interact in different ways and show the importance of diversity, which represent the trophic structure, which is the different feeding relationships in an ecosystem. In a food chain like this one, it is a transfer of food energy up the trophic levels from its source in autotrophs through herbivores to carnivores. The arrow traces the energy and nutrients through the trophic levels of an ecosystem.
Food chains are linked into food webs. Arrows point from one organism to the organism that it is eaten by. The base is a primary producer, which are autotrophs. Primary consumers, usually herbivores, eat the primary producers. Secondary consumers eat them, who are eaten by the tertiary consumers. The top organisms are apex consumers. Each category is a trophic level. Not shown in this image are decomposers. Fungi and bacteria are an example, and they use chemical energy and dead matter or waste to fuel metabolic processes and release nutrients that are recycled and can be used.
This pyramid shows the transfer of energy. Energy is transferred between trophic levels when one eats the other, but the amount of energy gained is actually inefficient. Energy is stored as biomass, which is transferred to the next level. This is stated in the 10% rule, which is a rule of thumb that states 10% of energy stored as biomass gets transferred up the next trophic level. Looking at this pyramid, you can see that 10% of the energy at 20,000 kcal gets transferred. Then 2,000, 200, 20, and 2. You could also see that the energy is also released mainly as heat and cellular respiration. Also, energy is not used because it is excreted through waste.
This is a biomass pyramid, which represents the total dry mass of all organisms in one trophic level. They usually narrow to a point like a pyramid because energy transfers at the top are very inefficient. This inverted biomass pyramid applies to aquatic ecosystems because the producer, phytoplankton, never have a large population size. They grow, reproduce, then are consumed. They replace their biomass at a rapid rate so they can support a biomass of zooplankton larger than their own.
Energy stored in organisms can be passed to others. Heterotrophs rely on the primary producers for energy. Energy flows in as sunlight and out as heat. Producers are important because biomass is key to understand how energy moves through the ecosystem and what organisms reside there. If they are removed, the ecosystem will fail because there will be no energy.
Hey, what is primary productivity?
Productivity is the rate at which energy is added to organisms to form biomass. There are two types: gross primary productivity, known as GPP, and net primary productivity, also known as NPP.
GPP is the rate at which solar energy is captured in photosynthesis. Producers use this energy for metabolism and cellular respiration. In simplest terms, it is the total primary production.
NPP is GPP minus the rate of energy lost through autotrophic respiration, meaning metabolism and maintenance. This is essential because it shows the amount of chemical energy stored that will be available to the consumers of the ecosystem. In simplest terms, it is the new biomass added. Plants capture about 1% of the solar energy and it becomes NPP. NPP varies among ecosystems and depends on many factors, including solar energy, temperature, and moisture levels.